Hi, good afternoon, everyone. Can you hear me okay? All right, great. I'm going to have a low-tech presentation today and just walk you through some potential, current and potential climate change impacts to the New York region. But first of all, I just want to thank the Peace Islands Institute and my fellow panelists here for having me here today, and you for coming and listening about some of these issues. So again, I want to go over some impacts of the New York region. So that's going to kind of include what we've seen historically and what we can reasonably anticipate for the future, and then sort of focusing on the case study of Sandy last year. So just so we kind of start on the same page, I'm sure you have all heard a lot about climate change, and a really simple physical science explanation is that it is due to an energy imbalance in the climate system, which is driven by an increase in greenhouse gas concentrations since the start of the Industrial Revolution. This has enhanced our natural greenhouse effect and driven up our global average temperature, hence the term global warming, which I'm sure you also have heard. This manifests in regional changes in temperature and precipitation, and is also a driver of global sea level rise. There are also some other impacts that have been introduced already to you. But I would like to focus on those three, and in particular, precipitation and sea level rise, just in the interest of time and its relevance to Hurricane Sandy. So just starting with precipitation or rainfall, probably more often you hear, over the period of 1900 to 2011, we've seen a slight increase in average annual rainfall in New York City. And we've also noted that the year-to-year variability, so that just means the variability in rainfall. So one year it could be higher, one year it could be lower. That actually has increased in the second half of the 20th century compared to the first. And that's important as it has implications for flooding, especially in urban areas. So if you have one year that's dry and one year that's particularly wet, that's definitely of concern for disaster planning. And then moving into the future, we can expect this increase in precipitation to continue. And it will be, historically it has increased about 1.4% per decade. So that probably doesn't seem like a lot. That may continue into the future. We're reasonably confident in that. The more important and subtle point here is it's actually the character of rainfall that's changing. So we have high confidence that these extreme precipitation events are going to increase in both frequency and intensity. So while in the annual average, it might not be increasing that much, we're going to be receiving the same amount of rainfall in more intense bursts. And that's really where the danger of flooding and possibly coastal storm surge might come into play. Dr. Chandler also mentioned some recent study by the IPCC that alluded to tropical hurricanes. So as he said, we don't have a very long time series history of hurricanes in the New York region. The kind of weather events that we're used to experiencing are more like nor'easters. So we don't have very conclusive evidence yet about the frequency of hurricanes, although we do have fairly high evidence that the intensity of these hurricanes will increase. So in general, I think that we can probably reasonably expect more extreme precipitation events in the New York region. And also a climate variable that was highlighted before is sea level rise. So as Dr. Chandler mentioned, had about a foot of sea level rise since 1900. This is basically due to two factors. One is glacial melt, so adding just more volume into the world's ocean. And the next is thermal expansion. So for those of you who paid attention to chemistry in high school, temperature and volume are related. So as temperatures increase, so does the volume. So this is contributing to sea level rise around the globe. In New York, although the contribution is almost negligible, it's quite small. We actually have land subsidence, and that's due to multiple factors. Sort of technical and maybe not worth going into, but it's just something to be aware of. So these trends there's very high confidence that they will continue. So the middle range scenario for the 2050s is about 1 foot to 2 foot increase relative to 1970 to 2000 baseline. So, generally when you start throwing around these numbers to people, that, you think about 2 feet, you think about 2 feet of snow in front of your house in the winter, and you're starting to, although, snow's a lot different than rain, you're starting to get just the idea of, how much this could drastically change coastal areas. So this this that's right. So this sea level rise is clearly going to be a contributing factor to more coastal flooding into the future, and this is particularly problematic because now you're considering that if the base sea level is already higher, it means that as we move forward, less and less severe events are going to start having impacts that are more sandy-like. And then if you recall from when we were talking about precipitation, if we're expecting an increase in extreme events, that's very problematic when you're combining it with higher sea levels. So this all merits a lot of discussion and research, but there are some things that we know that should be factored into resiliency planning for New York City. So that's probably a good segue into Sandy. So I would just like to, again, highlight some of the historic nature of the storm, which, again, you saw in Dr. Chandler's presentation. So Sandy actually broke 16 historical storm tide levels along the East Coast, and one of those was in New York City. And this historic nature of the storm was largely attributed to the westward direction that the hurricane was moving when it made landfall, and also that it coincided with high tide. So what I would like to talk about with the westward direction, it was incredibly anomalous, and it was actually great that you showed that storm path slide. So since 1951, there's been 9 other hurricanes that have made landfall in similar proximity to Sandy to the New York region. None of them have been traveling in a westward direction, all north to northeast. So this westward direction is really what brought on the high coastal storm surge, and basically combined with how the tides naturally are to combine to form very high tide levels. So in climate science, we like to talk about probability a lot, and what we use to define these things is return period. And you've probably heard about this a lot reading articles about Sandy. So the return period is a statistical measure of history. So if you have a data set, you would count, and you're interested in a particular event, you would count the number of times that it occurred in your data set and use that to define a probability. So the probability of the westward movement of a hurricane in this region was about a 1 in 700 year chance. And the storm tide levels that we saw was about a 1 in a 1,570 year chance. And the second of those two facts is a little problematic because our historic record doesn't actually go back far enough to reliably quantify it as some of the other statistics that we use. But it's just to give you an idea of that Sandy was really phenomenal in terms of anything that we've seen on the observed record. And so this brought into the discussion the question of, is this due to climate change, or how much can we attribute to climate change? And that's what I would kind of like to talk to you guys about. So the question of attributing a single weather event to climate change has been historically sort of difficult because by definition, climate is the average of weather over about a 30-year period of time. So it's hard to say that one particular weather event is due to climate change. And the way that we usually like to explain it, which you might have heard already, is using this concept of climate dice. So if you have a regular die numbered 1 through 6, each face has an equal probability of being rolled. And that's what we could consider our sort of historical situation. But you can alter those odds. Let's say I now have a die that I've added 4 sides to, but I all labeled them 6. So it's pretty clear that now there's a much higher probability of me rolling a 6. But now, so let's say I have that altered die, which we can, say that's maybe the influence of a climate change impact, and I roll a 6. That could have happened historically, but we can certainly say that the probability of that happening was much greater in the latter case. So I hope that it isn't too confusing and gives you an idea of that climate is essentially changing the odds of some of these events occurring. And to bring that back to sort of the more concrete example of Sandy, today our annual probability of experiencing Sandy-like flood levels again is double than what it was in 1950, just due to the sea level rise that has occurred due to climate change. So that's just an example of a climate variable that is essentially changing our probability of experiencing Sandy-like flooding or Sandy-like conditions. And as I mentioned before, sea level rise coupled with precipitation is really the concern. So I would like to sort of conclude with what additional research we need to fully understand how our odds are going to change into the future, and sort of what we know about climate change and how that can contribute to resiliency efforts. So I've listed a couple of things here. We need to understand how odds are changing and how they're going to manifest over time. And that's not only with sea level rise, but also precipitation, temperature, atmospheric circulation. Those are all going to affect the storms that we experience and how we experience them. Additionally, there needs to be a lot more attention in New York City to tropical hurricane systems. We need to understand that if they will become more frequent, what the return period that we should expect due to these changing climate impacts. And also there has been some suggestion that the westward heading direction of the storm was influenced by atmospheric changes that were induced by climate change. So that certainly isn't a fact yet, but there has been some initial research on that, and that needs to be investigated to get a better understanding of how likely this is to happen in the future. And then, as my fellow panelists have discussed, understanding of the coastal flooding maps and the populations that are vulnerable, or not only populations but also infrastructure that is supporting them. We need to understand how these patterns are going to change in the future and how we can make them more resilient. And actually, if you are looking for more resources, another excellent program that the Mayor's Office of Long-Term Planning and Sustainability has established is the New York City Panel on Climate Change. And they have contributed to a lot of New York City specific research. So I would encourage you to go look at some of those statistics, and I look forward to any questions that you have. Thank you.
Thank you very much, Ms. Sutton.